American industry loses over $2 billion in profit annually due to flat tires caused by cuts, punctures, or improper maintenance. Costly downtime is a thing of the past when tires have been flat-proofed with Arnco's products. This video will show you the proper procedures for flat-proofing a tire. It is extremely important that you learn these techniques. Let's take a few minutes to review the proper procedures for filling tires, the required equipment, and some precautionary safety steps. These are the things you need to know and the skills you must master in order to do the job properly and safely. Here is the necessary equipment required for flat-proofing. Arnco's Flushless II pumping system. Flat-proofing log for record keeping. Totes or drums. An air compressor capable of 21 CFM at 80 psi. A cleaning solvent such as 99% isopropyl alcohol. Hypodermic needles. Mechanic's toolbox. And rags for cleanup. The following items are required to provide a safe working area: safety glasses and chemically resistant gloves, a fire extinguisher, tire safety cage, first aid kit with eye wash stations, and MSDS sheets. Proper ventilation is necessary to prevent exposure from solvent and flat-proofing vapors. Due to the combustible materials you will be handling, there should be no smoking, grinding, or open flames in the workspace. No smoking signs should be posted in these work areas, and spectators should be carefully monitored when they are around this equipment. Refer to OSHA guidelines for additional safety information. Compliance is unique at each location and should be in accordance with all local, state, and federal regulations. These are the procedures to follow for flat-proofing a tire. Any pneumatic tire can be flat-proofed regardless of pressure or rated load specifications. The inside of the tire must be clean and dry. Tire contaminants such as water, sealants, glycol, calcium chloride, soaps, bead lubricants, or even dirt must be removed from the tire. If the tire is rinsed, the inside of the tire must be dry prior to flat-proofing. Wheels should be inspected for cracks, metal fatigue, and corrosion. Bent, cracked, or rusted wheels are a safety hazard and could result in a premature wheel or tire failure. Therefore, they should not be used. All new tires should be pre-stretched for 24 hours before filling. Inflate new tires to the maximum rated inflation pressure and maintain this pressure for 24 hours at room temperature of approximately 72 degrees Fahrenheit. Pre-stretching the tire ensures that the tire will be filled to its capacity and will minimize long-term carcass growth during service. For tube-type tires, always use a new properly sized tube. Wheels that require the use of flaps must be filled with the flap in place. If the flap is removed, the tube has a greater chance of rupturing during the filling process. Used tires do not need to be pre-stretched and will take more flat-proofing product than a new tire. The best results and value are obtained when flat-proofing new tires. Material. Flat-proofing materials should be stored indoors in a controlled environment of 72 degrees Fahrenheit or warmer. Never store flat-proofing materials outside. Prior to processing, the material must be at least 72 degrees Fahrenheit to ensure proper mix and curing times. During cold weather processing, allow for extra curing time. 24 to 48 hours is recommended. Arrange totes or drums so that the A-side product is on the left and the B-side product is on the right. Arnco's flushless pump should go between the totes or drums. The lower cylinders of the pump are labeled for each side. When moving the pump or changing totes or drums, care must be given to keep the hoses on the correct side. When hooking up new totes, inspect the ball valve for damage that may have occurred during shipping. Remove the shipping cap and foil seal. And apply a thin coat of grease to the threads of the tote connector and screw onto the ball valve. Hand tighten only. Remove the dust cap from the cam lock on the supply hose. Apply grease to the tote connector and connect the cam lock to the tote connector. Lock the cam lock in place by pulling back on the handles. Repeat this procedure for the other side. Arnco's A-side product is sensitive to moisture. It requires the use of a desiccant to remove any moisture from the air as it enters the tote. To install the desiccant cartridge, punch several holes in both sides of the canister. On the canister there is an arrow which indicates the direction of the airflow. The arrow must be pointed towards the tote. Remove the white 2-inch center bung on the A-side tote. Grease the threads of the desiccant holder and screw the assembly into the center opening. Place the filter in the desiccant holder and tighten the hose clamp. Make certain the inspection window is visible from the front of the tote. Change the cartridge when the inspection window turns pink. Flatproofing process. The Arnco flatproofing material is injected into the tire through the valve stem. At the same time, air is removed or vented through an opening or a needle at the 12 o'clock position. Liquid flatproofing material fills the inside cavity of the tire. When the tire is full, the needle is removed and the hole is plugged with a nail. The tire is then pressurized for the correct application. The valve stem is then sealed and the tire is laid flat to cure. After 24 to 48 hours, a solid elastomer has formed. The tire is now permanently flat-proofed and can be put into service. Flat-proofed tires are pressurized not with air but with flat-proofing material. It is important that before you begin flat-proofing, you know the operating pressure of the tire. If you are uncertain about the pressure, refer to the manufacturer's data book or the yearbook by the Tire and Rim Association. Never pressurize a tire above the maximum pressure as indicated on the sidewall. In addition to pressure, you should know the estimated pounds of flat-proofing material necessary for each tire. Arnco has a flat-proofing weight chart in addition to a computerized flat-proofing estimator to help you approximate weights and costs for flat-proofing tires. This information will be useful as it will help you determine if you have enough material to do the job, and you can monitor the progress of each tire as it is filled. If your pump is equipped with a mechanical counter, often referred to as a stroke counter, you must convert the cycle count to pounds. The total pounds can be figured by multiplying the displayed count by 0.81. Electric counters display the total pounds pumped, while a mechanical counter displays the cycle count. There is a fundamental difference between pressurizing a tire with air and pressurizing a tire with Arnco flatproofing materials. Gases are compressible, liquids are not. Pressurizing a tire with air is a gradual process with pressure building slowly from the initial introduction of air. With Arnco's flatproofing process, the tire is vented during the filling procedure, so there is little pressure buildup until the tire is totally filled. Then the pressure builds rapidly with the pumping of a very small additional amount of material. Startup procedures. Remove the manifold head, mixer and fluid gun from the solvent container and wipe off any excess solvent with a dry rag. Visually check to ensure all items are free from any residue. Starting with the mixing tube, insert the white mixing elements as follows. Position the mixing tube with the tapered end down and insert the flat end of the first element into the mixing tube stopping 1 inch from the top. Next, insert the second element into the notch of the first element and push down, again stopping 1 inch from the top. Repeat the procedure for the third element. You must always use 3 mixing elements. Do not use broken elements. Always keep an extra set of elements on hand. Dry the solvent from the ends of the mixer and apply Teflon tape to the threads. Apply a coat of grease to the quick connects on the manifold handle. Holding the manifold head in one hand, pull up on the female quick connects. Attach the manifold head to the handle and press down until it locks in place. Next, attach the mixing tube to the coupler on the manifold head and tighten. Attach the smart gauge to the gauge air stem. If using the whip hose, attach it to the end of the mixing tube and tighten all connections. Complete the assembly by attaching the fluid gun to the end of the whip hose on the mixing tube. Adjust the air regulator on the pump to 80 psi. Make certain the manifold hand valve is closed when turning the pump on. Open the ball valves on the A and B side totes. Open the white 2-inch bung to vent the B side tote. Check to see if the drain valve and gauge valves are closed. If they are open, close them before operating the pump. Turn the pump on and open the manifold hand valve and run 2 cycles of product through the system into the waste bucket to clear out any residual solvent. Prepare a quality control sample by pumping a small amount of material into a small Ziploc bag. Label the sample with the time and date. Lay the sample with the tires that have been flat-proofed. This will serve as a visual indicator of the material during the curing cycle. After the tires have cured, the samples should be retained for future reference should any problems arise while the flat-proofed tires are in service. Since the material is injected into the tire through the valve stem, it is to your advantage to use the largest valve stem available. Due to the larger inside diameter, air-water valve stems can reduce filling times by 50 or 60%. Considerable filling time can be saved by simply changing to an air-water valve. Valve stems that are angled are more restrictive and will take longer to fill. Whenever practical, air-water valve stems should be used. Position the tire vertically in the tire cage with the valve stem between the 4 o'clock and the 8 o'clock position. Remove the valve core or air-water valve from the tire that has been inflated for pre-stretching and load the core into the fluid gun. Most small tires will completely deflate before you can attach the fluid gun to the valve stem. Here's a time-saving tip. When filling tires using an air-water valve, you can connect the fluid gun to the stem and use the core extractor in the fluid gun to remove the air-water valve. This step works only with the air-water valve. Regular cores should be removed by hand and inserted into the proper core holder. Reset the flow counter to 0. As stated earlier, before processing can begin, you must know the operating pressure of the tire you are filling. In most cases, it will be the recommended air pressure for that application. Open the hand valve on the Flushless II manifold and begin filling the tire. Frequently turn off the hand valve and open the pressure valve on the accessory stem to check the internal tire pressure. When the internal tire pressure reaches 50% of the operating pressure, insert an air bleed device, such as a hypodermic needle, at the 12 o'clock position in a tread groove. The needle only needs to puncture the tire deep enough to vent the trapped air. Stop inserting the needle once you hear air escaping from the tire. For steel-belted tires and casings greater than 12 plies, you will need to drill a 7/64 inch hole through the tire to assist with needle insertion. Use of Arnco's needle inserter will make this much easier, and you will avoid damaging the needle. Turn the manifold hand valve back on and continue filling the tire. To keep the pressure in the tire from dropping too quickly, place your finger or thumb over the needle to stop the air from escaping. If tire pressure drops too low, a tubeless tire may lose its bead seat, and a tube-in-a-tube type tire may sag, possibly tearing the tube with the needle. Continue pumping. The tire is full when material flows from the needle. Close the manifold hand valve. Remove the needle and plug the vent hole with a nail or sheet metal screw. Open the pressure valve on the manifold and check the internal tire pressure. Turn on the manifold hand valve and pressurize the tire to its recommended operating pressure. Remember that fluids are not compressible. All tires, especially small tires, will pressurize quickly. If the tire gets overpressurized during the filling process, close the manifold hand valve and open the drain valve. Pressure inside the tire will force the flatproofing material through the drain valve, reducing the tire's internal pressure. Close the drain valve to check the pressure. Once the correct pressure has been reached, close the drain valve. The valve core can now be inserted. After the tire has been pressurized to the recommended operating pressure, leave the pressure valve open. Depress the plunger on the fluid gun and install the valve core into the valve stem. Pull back on the plunger. If the valve core is seated, the pressure on the gauge will drop to 0. It is now safe to disconnect the fluid gun from the tire. If you have more tires to fill, reset the flow counter and repeat the procedure for the other tires. For tube-type tires that require drilling, it is best to pre-drill these tires before mounting. If pre-drilling is not an option, apply a vacuum to the tube with a tube deflator before flat-proofing. The tube deflator will collapse the tube inside the tire, giving you a few inches of room to safely drill a pilot hole through the tread. Use a short drill bit when performing this procedure. Remember that you are only drilling through the tire. You don't want to damage the tube. After you have drilled the tire, the tube must be reinflated before flatproofing. This step is needed to reseat and fill the tube with air. Another option is to place a patch on the tube in the area where the tire will be vented for reinforcement. The filled tire must now be laid flat to cure. Tires can be placed on pallets to make handling easier. During winter, place tires on pallets. This will help maintain the temperature of the tire during the cure. Write the weight, stroke count, and PSI on the tire. After you have finished flatproofing, you can record the data in your flatproofing logbook. This logbook is used to record processing data for the customer and warranty information. Do not overpressurize tires. In addition to the possibility of a violent rupture, overpressurizing will cause crowning and possible splitting of the carcass upon impacting an object such as a curb or pothole. Once the material has cured, there is no way to correct this problem. Underpressurizing the tire could cause excessive flexing of the casing and material, which may lead to overheating and eventual tire failure. Warmth speeds the cure. The minimum processing and curing temperature is 72 degrees. Tires flat-proofed and stored at 72 degrees require a minimum of 24 hours to properly cure. If 72 degrees cannot be maintained, longer curing times of 48 hours or more will be needed before the tires can be returned to service. Tires should be processed and cured in a warm environment whenever possible. Cleanup. After the last tire has been filled, the equipment can now be shut down. Every person certified to use this equipment must follow proper shutdown procedures. Begin by checking the position of the cylinders. The cylinders must be in the lowest position so that the cylinder rods are completely submerged. Slightly open the manifold hand valve over the waste container and close it when the cylinders are at the bottom. Turn off the main air supply to the air motor. Open the manifold hand valve once again over the waste container to relieve the pressure in the cylinders. Close the hand valve when the pressure on the cylinder gauges shows 0. Hang the manifold body on the flushless pump. Remove the manifold head from the hand valve and place the head and mixer assembly in the flush bucket. Manifold head in first. Remove the fluid gun and whip hose from the mixing assembly and place in the flush bucket. Disconnect the mixing tube from the manifold head, leaving the coupler on the head. With the ejection rod, remove the mixing elements from the tube. Clean mixing elements in the solvent and store them in a safe place to avoid breakage. Clean the mixing tube with a brush. Place the mixing tube in the flush bucket. Next, clean the fluid gun plunger in solvent and open the drain valve on the whip hose. The mixer and whip hose must remain in the flush bucket during storage. The solvent level must be high enough to completely cover all items. Keep all solvents covered when not in use. Following these procedures will ensure simple reassembly. For tire removal and rim salvaging, you will need a reciprocating saw and several types of blades. The size and type of tire you will be removing determines the blade type and length. Tire removal is a two-part process. First, you must remove the tire from the cured flatproofing material. Second is to remove the flatproofing material from the wheel. Use a short sawtooth blade for radials and a short knife edge blade for bias ply tires. First, lay the tire on its side. Using a reciprocating saw, start at the shoulder of the tire and make a diagonal cut to the middle of the sidewall. Proceed to cut around the tire, stopping at the shoulder. Cut across the tread and repeat the procedure for the other side. Remove the tire from the flatproofing material. Using a knife edge blade, cut across the cured flatproofing material from bead to bead. If needed, the flatproofing material can be cut into 4 sections to make removal easier. Remove the flatproofing material from the wheel. Maintenance. Proper maintenance is the key to long equipment life, reliability, and efficiency. Flatproofing does not have to be a messy procedure as long as your work areas are kept clean and the pump in good working order. On initial setup or after cylinder replacement, the wet cup should be filled 1/4 of the way with throat seal lubricant. This oil provides critical lubrication to the piston rods and helps seal the Teflon packings. With normal use, the TSL oil in the wet cup will change color as the flatproofing material penetrates the seals. This is normal. The A-side material will begin to harden once it has accumulated in the cup. When material begins to gel, scoop the material out with your finger. After the cup has been cleaned, refill with clean TSL oil. TSL oil will evaporate and should be checked weekly even if the pump is not used. The Teflon seals under the cup require periodic adjustment. Use the spanner wrench supplied with the pump to tighten the cup seals. Over-tightening will damage the seals. Hand tighten only. For troubleshooting and service procedures, please refer to the Arnco Flatproofing Technical Manual or contact the technical hotline